Question, is hydrogen a powerful antioxidant? Welcome to another Q&A video, and thank you, my peeps, for voting. This is a fun question today, so let's go ahead and dive in. All right, so let's go ahead and start with the term powerful. You see this online. A lot of different people market hydrogen as a powerful antioxidant, and even just the term powerful in this type of description, I think points more to marketing than it actually does to the science. So let's actually look at what the literature is saying about hydrogen's antioxidant properties. So the first thing I would state is that right now, based on what the scientific literature is saying, is that hydrogen is not a powerful conventional antioxidant or free radical scavenger. In fact, it's quite weak, and this can be seen in a number of studies that they have been talking about this. One, you can look at the rate constants of these antioxidants and in comparison to hydrogen. So for instance, the hydroxyl radical and vitamin C and hydrogen. Well, vitamin C's rate constant is about 1,000 times higher than hydrogen. So it makes no sense as to let's say hydrogen's ability to be able to react with the hydroxyl radical. Vitamin C is going to be able to perform better than hydrogen. And so this is what the literature points to, and this is this weird thing. We know that throughout the studies, we can see that hydrogen is actually reducing the hydroxyl radicals levels within cells. And so right now, what is actually being stated about it is that hydrogen is not very likely in a cellular system. The hydrogen reacts with hydroxyl radicals in a conventional method. If it does, it will do it maybe 1 out of every billion, something like that. But it does not appear, based on hydrogen's ability to be able to react with this particular molecule versus other ones such as lipids, proteins, DNA, the hydroxyl radical will react with virtually anything. It's going to be preference to react with other molecules than it would hydrogen, just based on its simple rate constants. And so I'll leave some of that data within the description of this video. Now, let me be clear. I'm not saying that hydrogen's ability to react with the hydroxyl radical is not a legitimate redox reaction. There are studies that have been shown that in a cell-free system, hydrogen reacts with the hydroxyl radical, and so we know this is a legitimate redox reaction that can take place. It's just within a cellular system, there's so much more competition that that is not preferable for the hydroxyl radical to choose hydrogen, which has a lower rate constant than something else that might be, like I said, vitamin C or glutathione or lipids or proteins or anything, DNA. It is more preferable or is more favorable. That potential is more favorable there. And so, so that was point number one. Now, point number two is this antioxidant effect or conventional antioxidant effect or property of hydrogen that we might look at cannot explain all the potential benefits that is being seen in the literature. I mean, this has been articulated a lot within the literature that they've talked about this, that these effects we see cannot just be towards hydrogen's antioxidant properties in the conventional sense of free radical scavengers. And so how is hydrogen actually functioning as a antioxidant then? So I think it'd be better stated that hydrogen has antioxidant-like effects. Not that it's a powerful antioxidant, but it has antioxidant-like effects. And so if it's not doing it through the conventional, then it appears that hydrogen is doing it based on what the research is saying through being a signal modulator or signal transduction. It's influencing metabolic pathways that upregulate our own antioxidants. So there's a few mechanisms that hydrogen looks to be doing these things. One is the NRF2 pathway, which let's just say is our master regulator for our antioxidant defense system of the cell. And so hydrogen has been shown throughout the literature to upregulate the NRF2 pathway, which upregulates all these cytoprotective enzymes and proteins and antioxidants, glutathione, catalase, superoxide dismutase. A lot of these antioxidants that are conventional antioxidants, they're able to donate their electrons and not become overly overly oxidize themselves. And then we know hydrogen appears to be able to do that. We also looks like hydrogen could be the other couple pathways would be the Fenton reaction, and I think the Haber-Weiss reaction. These particular reactions involve hydrogen being able to possibly interfere with this reaction because hydrogen's upregulation of catalase can reduce hydrogen peroxide, which hydrogen peroxide hydrogen peroxide can actually go on to produce a hydroxyl radical actually within a proximity of iron. So this is dealing with these particular reactions, the Fenton reaction, the Haber-Weiss reaction. Hydrogen may be actually reducing hydroxyl radicals through this as well. Now, these are just some reactions that are under investigation that they're looking at, but it does like these might be some possible mechanisms that hydrogen is actually regulating. Now, another thing to consider is that hydrogen is has selective antioxidant properties, right? So there's plenty of research that has demonstrated that hydrogen is able to reduce harmful free radicals and actually allow beneficial ROS, reactive oxygen species, to do their thing. And so this is something that's not necessarily known. Most people would think that, you need to reduce all free radicals, but there are beneficial free radicals that can act as signaling molecules that has really good benefits for our bodies. And so hydrogen has the ability to selectively reduce these, such as a hydroxyl radical and peroxynitrate. So these particular molecules seem to serve have no beneficial effects for our cells or our bodies. And so hydrogen is able to do that. And this leads me to the third point, which is, I believe, is really important about hydrogen's antioxidant properties, is that hydrogen seems to be able to prevent the excess production of these damaging free radicals. And so it's better to prevent the excess than actually have to mitigate the damage. So because of hydrogen's ability to have regulatory effects on redox homeostasis, our antioxidant level being where they should be and our free radical level being where they should be, hydrogen has this potential to prevent the excess amounts or production of these harmful free radicals. And so to wrap things up, basically hydrogen is not a powerful antioxidant or conventional antioxidant. It's not a conventional free radical in the sense that we think of antioxidants like vitamin C or glutathione. It does have antioxidant-like properties that is through signal transduction or being a signaling molecule, signal modulation, and it does appear to do this quite effectively. And number three, hydrogen's not just doesn't have the ability; it has the ability to aid in prevention of excess production of free radicals. And so hydrogen does appear to be an effective antioxidant-like agent in regulating the cell. And so that would be my answer for hydrogen being, is hydrogen a powerful antioxidant? All right, you guys, so we're going to catch you next month with another Q&A video. Make sure you vote. We will post these on all of our social media platforms from YouTube, Facebook, Patreon, Twitter, Instagram, etc. So please make sure you guys vote on these, and I'll go and do my best at answering the question. Deuces.